So learning outcome 14. So we introduce this new idea of what we mean by resistance. So it's the ability of an object to oppose the flow of current. I.e., a large resistance will result in a small current. And the unit of resistance is the ohm, OHM. And does anyone recognize that Greek letter that's used to abbreviate it? 1 kilo ohm equals 1,000 ohms, so you will need to use that at times. To 15. So in our investigation, we found that the current and voltage could be linked by a simple formula. So for one of the resistors we found it was V equals I times 0.1. For the other one we found it was V equals I times 0.15. Or in more general terms, we can now write V is equal to I times R. So we call that number R for resistance. As part of that investigation, but we want to get in this wee bit about graphs. A graph of voltage versus current, and I'm deliberately leaving a wee space there to sketch it, is a straight line. So in sketch terms, so if I plot a graph of voltage versus current, then we get a nice straight diagonal line. We found that wasn't the case for a light bulb, so the light bulb's a slightly more complicated situation we won't study just now. 16 and 17 together? No, it's not big. What we've got here is the formula, so that's what 16, learning outcome 16 is, basically state what the formula is, and then 17 is about using the formula. So if we start by stating the formula, it's just the one that we put in a wee second ago. But you'll generally find it easier if you use it in that form, right? Where the bit that you're working out, where everything that you could be asked to work out is on the top line. So put it in a wee box. Underneath it, we define what everything stands for and the units that go with each. So just to remind us, we've done this before, but just to remind us, I stands for current. That's the one that does tend to confuse people. Okay, so that's the definition of the formula. That's really 16. But then 17 is about doing examples and using that formula. So I'm going to do a couple of different examples. Start with one that's fairly straightforward. So what battery voltage would be required to provide 2 amps of current through a 6 ohm resistor? Question, it tells us what the current is. Right, the first number I come through as I read through the question is 2 amps of current. So in my answer I write down I equals 2A. And then reading through the rest of the question, through a 6 ohm resistor, so it's telling me that the resistance that I'm interested in is at 6 ohms. So I write down R equals 6 ohms. So the first step, what does the question tell me? Step 2, what is the question asking me to find? Now, usually that's obvious, but sometimes that's the whole key to the question. Right, it's asking me to find the voltage. So I put V equals question mark to remind myself. And now I can look through and think, well, what formula links these values together, I and R and V? Now, not surprisingly, it's a formula that we've just introduced. But if you're in an exam, right, you met 2 formulas last year, you'll meet more formulas as we go through this year, so part of your thing is selecting the right formula. And that's what this problem-solving method is about, right? Trying to help you select the right formula. You get a mark for selecting that right formula. Then we do what's called substitution, which means we replace any of the letters which we know their value, we replace it by the value. So if I go through and work through it, the first thing I come is a V. I don't know what that is, so I'll leave it as a V. Don't put a question mark in because you'll end up losing track of what it is you're working out. So if you don't know the value, don't substitute. Then the next thing in the formula above it was an equal sign. Then there was an I, but I do know the value of an I, so I put 2 instead of the I. In this example, I know that R is 6, so I put 6 instead of R. And now I've got a calculation, which I can quite simply do. So put it into your calculator. The final answer is 12. And I have to put the units in afterwards, so I put a V for volts. Example 2 then, we'll look at working out something on the right-hand side. Okay, so calculate the resistance, right? If 6 volt produces 3 amps of current. And once again, I want to stress in this methodical problem solving. So we go through the question, we write down what you know, okay? And then think about what we're being asked and how we link them together. The first thing I come across is this 6V. So you've got to recognize from the units that that's a voltage. If it says 6V, then it's V equals 6V. Right, those units go with that symbol. Now that's quite an easy one because they both use the same. Right, the symbol and the units for voltage are both V. The next thing I come across though is this 3 amps of current. So I put I equals 3 amps. And then I need to clarify, what's the question asking me? It's asking me resistance. What I do next though, and this might surprise you, I don't do any fancy reorganizing yet. I still just go with the formula as it will be written in the formula sheet, as it will be written in your exam cover. Right? You just write out the formula as it's given. V is equal to I times R. And then you do the next step again, substitution, step 2. So you go through and replace the letters that you know. So I know that V is 6, so underneath there I'm going to put a 6. Then my equal sign, And then I know that I is 3, but I don't know what R is, so I'll leave that as an R.
I thought I was 2.
Do is just swap round sides. So if 6 is equal to 3 times R, then 3 times R is equal to 6. Do you agree I've not changed anything in the formula there?
Nothing.
But I want my final answer to be R equals something. I've got it onto the left-hand side now, but I want it on its own. So how do I get rid of that 3 that's multiplying it? Michael? Divide it by? Yeah, divide it by 3. So if I want to get rid of the 3 it's multiplying, I need to divide both sides by 3. Okay? Now 3 divided by 3 is 1, and that leaves me just an R on that side. And now I can get my calculator out if you really need it and do the calculation of 6 divided by 3. Right, 6 divided by 3 is 2, and then I put the units in, omega. That one's pretty basic?
Yeah.
Okay. One more example then. Right, about as hard as it will get for now. I'm going to have to try and squeeze this in. So the last thing I'm doing to make this a bit difficult is introduce that kilo ohm idea. Right? And the other one that you might come across is sometimes the current might be written in milliamps, right, which are thousandths of an amp. But for this one we'll go with the idea that the resistance has been given in kilo ohms. So that's not that unusual. If I go through the same sort of problem solving again, V is 9 volts is the first one I come across. R is 2 kilo ohms, but what I want to do at that point is immediately convert that into ohms. 1 kilo ohm is 1,000 ohms, so 2 kilo ohms is 2,000 ohms, multiplied by 1,000. And I is my question mark here, trying to calculate current. Write out the formulas as given. I'm kind of having to squeeze it in a wee bit here. V equals I times R. Substitute, so I know that V is 9. I don't know I, but I know that R is 2,000. Trying to get I in its own, so this is not such an obvious number. Do you agree with that? So I'm going to go through all the steps. Swap both sides first of all. If 9 is equal to I times 2,000, then I times 2,000 is equal to 9. Now, how do I get rid of that times 2,000? Divide it by 2,000. And whatever I do to one side of a formula, I've got to do to the other. So you get your calculator out and you do 9 divided by 2,000 and it will give you a very small answer. Something like that. I've managed